As mentioned, the main goal of discussing differential equation and this series itself is on identification of solutions to identified differential equations. So let's talk about when can we say that a certain function is a solution to an ordinary differential equation. So the solution is actually defined in this manner. It's actually a function, probably in the term of y of x generally, that it has the following characteristics. Number one is sufficiently differentiable. Okay? It should be a differentiable function, meaning the derivative is present. And the second one is when substituted, and it's actually the real meat of this video, into the ordinary differential function, satisfies it identically, meaning it preserves the equality, okay, of the given differential equation. So the target here is to look for a function that is differentiable, and when substituted again into an ordinary differential function, the equation is satisfied. So the thing here you need to consider is number one. Okay, here's the possible task. This is how it would look like, rather. So this is how it would look like. Say for example, you are given with a certain ordinary differential function. Okay, so probably it's an equation. It contains dy over dx, or the first order derivative of y in terms of x, or other forms as long as it's ordinary derivative. Hence, it's called ordinary differential equation. And you will also be given here, okay, for some cases, you will given here with a function y of x. To verify, or not necessarily given, or that's the item that you're solving. To verify that this is a solution, once substituted there, together with, say for example, if this ordinary differential function has first order derivative, has first order derivative, or has second order derivative, you are to take the first order derivatives of this as well, and even second order derivative, so that when you substitute the results together with this on our ordinary differential function, if it satisfies the ordinary differential equation, sorry for that, if it satisfies that equation, then this is really a solution. Let me provide one example here, illustration, for us to be to understand this carefully. Let's say our ordinary differential equation is described as the first order derivative of y with respect to x is equal to 3y. Okay, so later on in the part of our series, we have a lot of steps to identify some solutions. Take note, some solutions, because there might be infinitely many solutions. Okay, so there are processes, methods, and techniques to that. But this time, let's just verify if a certain function, let's say here, y is equal to e to the power of 3x, is a solution of that. So this is now on verification. What if this is what you will get in your process? You have to verify if it's really a solution. So how should this process be done? The first thing here is, of course, take note, our ordinary differential equation has y, so y is already here. The second item needed is actually the first order derivative. Hence, let's try to get its first order derivative. So we derive both sides. And take note, this is an exponential equation. How do we derive e to the power of u? It's actually e to the power of u du. So it's itself e to the power of 3x and a derivative of the exponent, which is actually 3. In short, the first order derivative of y with respect to x for this given function is 3 e to the power of 3x. Now, we have y for this. Now we also have the first order derivative for this. To verify that this is really a solution of the given, let's substitute both and let's find out if it would be satisfied. So in the left side, it's this, the first order derivative. So you have here 3 e to the power of 3x is equal to 3 times your y, which is e to the power of 3x. So question mark, obviously 3 e to the power of 3x is equal to 3 e to the power of 3x. It's satisfied. Therefore, we can really say that this is a solution of the given ordinary differential equation. So in the next few videos, we have to try verifying a given function whether they are actually samples of solutions of provided differential equation by this process. But nevertheless, the point here is the solution of an ordinary differential function is a function that is, of course, should be differentiable. And at the same time, it would satisfy the equation when substituted together with all of its versions, first order derivative, second order derivative, and so on and so forth. Thank you very much for watching.